Mary was an innovator in many areas, from her engines to her electric systems. But one area which really stands out is her hull, which was designed to be the ultimate weapon against the icy waters of the North Atlantic. Welcome back to the channel. We've been uncovering the secrets behind some of the world's most famous ships this series, and we're bringing that same treatment to Mary today. If you like stories like this, please do consider subscribing so you don't miss any new videos. And as always, thank you very much for your support. Now, there are two things everybody knows about Queen Mary. First, she's very fast, capable of crossing the Atlantic faster than any ship before or since. And second, she has an extraordinarily full and busy life as both a troop transport during the Second World War and as a luxury liner afterwards. But what is UNT as well known is just how carefully thought through every single part of the ship was to make sure that not only could she keep up with her sister, but also to ensure she was more comfortable and safer for her passengers than any other ship afloat. So let's take a look at Mary's fascinating design secrets. Let's start off with her bows. Now, when Mary was built, it was known that speed was essential. The expectation was that the Olympic class would be competing with ships such as the Lusitania and the Mauretania, and it was expected that they would have to race across the Atlantic to get there first. In order to make sure she was ready for this, the bow was designed to cut straight through the water without creating any turbulence, meaning that the forward thrust of the ship wouldn't be impeded by any resistance. To help with this, the ship had a long, narrow, and pointed V-shaped bow. This is different from modern liners, which usually have a bulbous bow which looks almost comical compared to the sleekness of something like Mary. While the modern bow may seem like a better idea, it's actually not great for speed, but it does serve other purposes. In fact, the designer of Mary, Sir William Ceratops, did attempt to add a bulbous bow to the Olympic class, but after testing this, he quickly found that the effect on speed was too great to ever implement it. The added weight meant that even if it did reduce pitching, it would also increase the length of the ship, making it harder to steer and increasing the time it took to get up to speed. And so the streamlined V-bow stayed for the entire lifetime of the ship. The hull was designed to be incredibly strong. Unlike many ships, which used riveting to join the steel plates together, Mary used welding. Welding was seen as being stronger than riveting, which was the standard at the time. However, welding wasn't widely used because it was a difficult process and required specially trained workers. It was still relatively new at the time, having only been developed in the late 1800s, and it was also risky. If the welds failed, the ship could crack and sink. This risk was unmanageable until electric arc welding was invented in the late 19th century. This invention created a safer and more consistent way of joining metal plates together, making it ideal for ships. It made the welds stronger than rivets, and it was more reliable than riveting, meaning that the risk of cracks forming was reduced significantly. This was groundbreaking at the time and helped to improve the overall strength and safety of the vessel. But Mary's hull was designed for more than just strength. It was also designed to be incredibly rigid. This was partly done to reduce vibration and movement, but it was also done to improve her sea. You see, in the early 20th century, it was believed that a ship should be able to withstand almost anything that the sea could throw at it, and so the hull was designed to be incredibly strong and rigid to avoid catastrophic damage. Now, while this was good for safety, it did make the ship quite uncomfortable to travel on, especially during rough seas. See, the tighter the ship is built, the less likely it is to move around in the water. But it also means that any force applied to it will be transferred directly onto the ship itself. Now, this might not sound like a big deal if the force is constant, but if it's not, then it can cause some serious rocking and rolling. Modern ships have found ways around this problem by changing their center of gravity, either by changing the shape of the hull or by adding ballast tanks to allow them to shift the weight of the ship. This makes them much more stable, but it makes them less safe. That said, many of these features are there to stop the ship from tilting over completely, whereas the lack of stability in Mary was more of a minor irritation than anything else. But perhaps the most interesting part of Mary's hull is what lies beneath. When Mary was built, she was outfitted with the latest technology in hull protection. Her bottom was covered with a special type of paint that was designed to resist the growth of marine organisms such as barnacles. This was important because barnacles could cause drag and reduce the speed of the ship, not to mention the fact that they can be dangerous to the paint was also designed to resist corrosion from the elements, which was a major problem for ships at the time. Ships would often have to be pulled out of the water every few years to be repainted, which was expensive and time-consuming. The paint used on Mary's hull was a breakthrough at the time, and it allowed the ship to stay in service for longer periods of time without needing to be painted. But this was far from the only thing protecting the hull. Mary was also fitted with a special type of steel that was designed to be more resistant to the cold temperatures of the North Atlantic. The steel was also coated with a layer of copper to prevent corrosion. Copper is a highly conductive metal, and it acts as a sacrificial anode, corroding instead of the steel. This was another innovation at the time, and it allowed Mary to stay in service for longer periods of time. having to be repaired. All of these features were designed to keep Mary at the top of her game throughout her working life. But no amount of preparation could have predicted the harsh realities of the North Atlantic. On April 14, 1911, the captain of the Titanic received a warning about icebergs in the area. He immediately relayed the message to the crew, but it was too late. The Titanic had struck an iceberg and was doomed. This was a major blow to the public, who had believed that the Titanic was unsafe, but it also sent shockwaves through the shipping industry. People began to question whether or not other ships were also at risk, and the answer was yes. The Olympic class was immediately called into question. Had the same thing happened to one of them, then it would be a disaster. And so changes had to be made. One of the main problems with the Titanic was that it was too compartmentalized. The ship had been designed with watertight compartments that were supposed to keep the ship afloat if it was damaged, but this actually caused the ship to sink faster. The compartments trapped air, which made it harder for the water to escape, and this caused the ship to sink faster. The Olympic class didn't have this problem. Their hull was designed with fewer, larger compartments that allowed air and water to move freely. This made the ship more stable, and it also made it less likely to sink. But it wasn't enough. Mary had to be changed. The changes made to Mary's hull weren't just cosmetic. They were designed to make the ship more efficient and to reduce the rocking and rolling that occurred when the ship was sailing in rough seas. The changes also made the ship more environmentally friendly by reducing the amount of fuel that it consumed. But these changes weren't enough to save the ship. In 1936, Mary ran into an accident that nearly sank her. The ship was sailing from Southampton to New York when it hit an iceberg. The ship was badly damaged, but it was able to make it to port. After the accident, Mary was refitted with even more improvements to make sure that she would be safe for passengers. The ship was refitted with stronger steel, improved welding, and a new type of paint that was even more resistant to corrosion. These changes made Mary one of the safest ships afloat, but they also made her slower. After the Second World War, people's expectations for ocean liners had changed. They wanted faster, more luxurious ships that could cross the Atlantic in record time. And so Mary was retired in 1967. She had been a pioneer in many ways, but she was also a victim of her own success. Her design had been copied by other shipbuilders, and the competition was fierce. The Queen Elizabeth line, for example, was much faster and more luxurious than Mary. This, along with the changing times, led to Mary's retirement. Even so, Mary's legacy lives on. Her design innovations helped to shape the future of ocean liners, and she remains an iconic piece of maritime history. And that's the story of Queen Mary's fascinating design secrets. If you like stories like this, please do subscribe so you don't miss any new videos. Thanks very much for watching, and I'll see you next time.